Have you ever wondered why highly advanced aircraft still rely on millions of rivets rather than welding? In this era of advanced technology, welding has become a very common technique in the manufacturing industry. However, in aviation, traditional methods like riveting remain the primary choice. Why is that? Let's dive deep into this topic in this video. Welding is a process of joining metals by melting and fusing them together. This method is widely used in various industries, from automotive to shipbuilding. However, in aviation, welding is rarely used. Instead, aircraft are assembled using millions of rivets to connect different components. There are several key reasons why rivets are preferred over welding in the aviation industry. First, rivets offer superior resistance to vibration and stress. During flight, an aircraft experiences various external forces, including strong winds and changes in air pressure. If welding were used, welded joints could develop cracks due to prolonged vibrations and mechanical stress. Rivets, on the other hand, offer better resistance to these conditions. Second, the materials used in aircraft construction play a crucial role. Aircraft are made from various materials, such as aluminum alloys, titanium alloys, and composite materials. Aluminum, in particular, is difficult to weld, while composite materials cannot be welded at all. Riveting allows for easier and more effective joining of these diverse materials. Third, the extremely thin nature of aircraft materials makes welding impractical. The outer skin of an aircraft is only a few millimeters thick. Welding could cause deformation or even burn through such thin materials, making it unsuitable. Rivets provide strength without damaging the structure. Another important factor is ease of maintenance and repair. Aircraft require regular maintenance, and components often need to be replaced. Riveted joints are easier to disassemble and repair compared to permanent welded joints. This makes them a more practical choice for long-term operation. There are various types of rivets used in aircraft construction, including solid shank rivets and blind rivets. Solid shank rivets come in several variations, such as round head, flat head, countersunk head, and universal head, each serving a specific function. For instance, round head rivets are used inside the aircraft to reinforce sheet metal around holes, providing better stress resistance. Meanwhile, blind rivets are used in structural areas where access to the backside is limited, making it impossible to use traditional rivet-setting tools. They are commonly applied in aircraft interiors and flooring. The installation of rivets requires high precision. A hole is drilled slightly larger than the rivet diameter, then the rivet is inserted and its tail end is pressed or hammered to form a second head, locking the joint. After installation, the joint is inspected to ensure there are no defects like cracks or gaps that could compromise strength. Beyond the reasons mentioned above, riveting offers other advantages. Rivets distribute loads evenly across the joint, reducing stress concentration that could lead to cracks. They also allow for more flexible designs, especially in complex shapes or areas requiring on-site assembly. Additionally, using the right rivet material minimizes the risk of galvanic corrosion between the rivet and aircraft materials. There have been incidents in aviation history caused by welding failures. For example, in the 1950s, some aircraft suffered structural failures due to cracks forming in welded joints. This led the industry to rely more heavily on rivets to ensure structural integrity and long-term safety. Although rivets remain the primary method in aviation, recent innovations are being introduced. One such development is friction stir welding, a solid-state welding method used in some modern aircraft, such as the Boeing 787 Dreamliner fuselage. This technique reduces the risk of cracks and enhances joint strength. Another emerging technology is structural adhesives. High-strength adhesives are being tested as an alternative or supplement to rivets in certain aircraft parts, helping to reduce weight without compromising structural integrity. Rivets are not only used in aviation but also in shipbuilding and large steel structures, such as bridges and skyscrapers. However, these applications involve much larger rivets and special installation methods, like hot riveting and cold riveting. In hot riveting, the rivet is heated until red hot before being inserted and hammered into place. As it cools, it shrinks, creating an extremely tight joint. Cold riveting, on the other hand, is used for smaller rivets, like those found in aircraft, without heating. So why do aircraft still use millions of rivets instead of welding? Riveting is preferred over welding in aircraft manufacturing for several key reasons. One of them is the material's resistance to heat. Aircraft commonly use aluminum and lightweight alloys, which can weaken or change their properties due to the high temperatures involved in the welding process. With riveting, the material retains its strength without the risk of distortion caused by heat. Additionally, riveted joints are more resistant to vibrations and material fatigue, which is crucial as aircraft experience significant stress due to changes in air pressure and turbulence. Compared to welding, which is prone to cracks at the joints due to continuous vibrations, rivets offer better flexibility in handling dynamic loads. Another advantage of riveting is that it does not require additional heat treatment after installation, making it more practical in production and preserving the material's mechanical properties. Furthermore, riveted joints are easier to inspect and test for reliability compared to welded joints, which can hide defects within the metal structure. In the event of damage, rivets are also easier to replace than repairing a welded connection. Riveting also allows for the joining of two different materials, such as aluminum with steel or composites, which is difficult to achieve through welding due to significant thermal property differences. Nevertheless, welding is still used in certain parts of an aircraft, particularly in internal structures or components that are not exposed to high loads. However, for primary joints in the fuselage, wings, and other high-stress areas, riveting remains the preferred choice due to its superior reliability and durability. However, technology is constantly evolving. With innovations like friction stir welding and structural adhesives, we may see a combination of more efficient and lightweight joining methods in the future. Thank you for watching this video. Don't forget to like, subscribe, and turn on notifications so you won't miss other interesting videos. See you in the next video.